Alright, so today we're going to talk about non-proportional lines, how to find them with just data. Remember, it's all about m and b, the slope and the y-intercept. We know the equation we're using right now is y equals mx plus b. What is m?
The slope.
The slope. And what is b?
Starting point.
The y-intercept. Or starting point or starting value. It's a bunch of things. I can't spell in there. So all these things it fills.
Wait,
Sit on my desk.
say?
Y-intercept. Thank you. So what we're really looking for, y and x are an ordered pair that exists somewhere on the line. We don't know where they are. If we knew one, we could find it based on knowing m and b. So what we're really looking for is slope and y-intercept. Now, important, the y-intercept, what are the coordinates of the y-intercept? What is the x-coordinate for any y-intercept?
B.
The x is
0.
0, comma, whatever the y-intercept is. Which means if I look down my table and I have an x that's 0, then I already know the y-intercept. Sadly, this first table doesn't have that, does it? How rude.
How rude.
Now, we can do a couple of things to get everything we need. Now, we did this in proportional relationships. Remember doing a little where we found the difference between them? What's the difference between 2 and 4?
2.
2. What's the difference between 4 and 6?
2.
Difference between 6 and 8?
2.
Okay, I love that. It makes it easier. So what's the difference between 22 and 32?
10.
And 32 and 42?
10.
And 42 and 52?
10.
Okay, so when we do it, we know that m equals rise over run or y over x. In this case, it's the difference in y. If you do a straight y, so we're going to do the difference in y over the difference in x. And we're actually going to introduce an equation for that here shortly. Okay? So this one, life worked out pretty good. I put 10 over 2. And what does that equal? 5. So my slope is 5, right? I found the difference in y over the difference in x. Good so far?
Yes.
Okay, so now, the easiest way to deal with this one is to regress.
What's that word?
What I mean by regression is it's going 2, 4, 6, 8. If I went this way 2, what would I get to?
0.
Which is where I want, right? Because if x is 0, then whatever y is the y-intercept. So here, how far are they regressing each time?
10.
So what's 22 minus 10?
12.
So what's the y-intercept? b equals 12, or the coordinates 0, comma 12. So now I can write my equation, right? So y equals 5x plus 12.
Whoa.
You see how fast that went?
Yes. Wait.
Mm-hmm.
How? Where'd you get 5?
5 we got from the slope. Do you remember that? So let's introduce an equation. So that works really well if your table is beautiful and clean. What if I only have 2 numbers? Two sets of ordered pairs.
That's not fair.
Then you got issues.
It's still about the difference in y over the difference in x, right? So let's do this. So m equals the difference in y, or, ready for this? Look at your yellow sheet.
Yep.
Look for slope. What's the equation?
Where do you see slope?
It says slope on the yellow sheet.
M equals y2
y2
minus y1
minus y1 over.
x2 minus x1.
That really is, remember when they sub, when you've got a number sub, that just identifies which of the variables you're using. They really just gave us the exact equation we need to do with any. If they gave us an ordered pair, no matter what they were, we can get them. Here's the trick. Label your ordered pairs. If you don't label your ordered pairs, you're going to grab the wrong one from the wrong side and make sad. So we're going to call this x1 and y1, right?
Yeah.
They're an ordered pair, aren't they? Then we'll call this pair x2, y2. So now I can say m equals, what is y2? 15 minus y1, 8.
Oh, goodness gracious.
Over x2
2,
minus
1,
1. What's 15 minus 8?
7,
And what's 2 minus 1?
1,
And 7 over 1 equals?
7.
So let's take another way to find b. Did it make sense with the regression before?
Yes.
I could easily regress here, couldn't I?
Yes.
In fact, I will, just for the heck. Look at this, they're going up exactly in order, right? If I go 1 down, what am I at?
0.
And this one said it was 7, so 7 down from 8 is?
1.
So I really know it, but let's verify. Let's show you that it works. I can stick in an equation. I can use any pair of x and y coordinates, right? I'm going to use 3 and 22 for no other reason they're hanging there. And I'm going to write y equals mx plus b. That's our equation, right? So I'm going to take the y from this coordinate pair. What is y?
22.
22 equals, we know what slope is, right? 7 times 3 plus b. So 22 equals, what's 7 times 3?
21.
21b plus b. Now, how would I get the 21 off the side with b? We're looking at an equation just like we looked at before, right? We've seen these equations. We know that we can do anything on one side, we can do the other. So if I want to get b all by itself, how do I get the 21 off this side? Subtract 21 from both sides. So this one will go away. What's 22 minus 21?
1.
So 1 equals b. Did you see how I used a couple techniques to find b?
Yes.
X and y can be any ordered pair. So if you get two ordered pairs, you can find the slope by doing y2 minus y1 over x2 minus x1. And then find, you can spit that out. And then find b by taking one ordered pair and sticking it back into the equation, right? So in the end, our equation becomes y equals, well, what's our slope?
Plus 1.
27.
7x plus 1.
B.
Now, we love graphs. Graphs are so much easier than everything else, right? What is b? What is it defined as? What do we call it? Starting point or? Y-intercept. So look down the y-axis and find where the line intercepts. It's right there, right? So what's that coordinate right there?
1.
So the coordinate is actually 0, comma 1, right? That gives me b, doesn't it?
Yes.
Now, how do I find slope? Rise over run is the easiest. Because I have actually two pairs here, I can do y2 minus y1 over x2 minus x1. I tend to be lazy when it comes to graphs. I'll go ahead and use theirs. I'm happy with it. I like rise over run. Nice right triangle makes me happy every day. So we count down. 1, 2, 3, 4. So this side is 4, and then 1, 2. What's the rise?
4 over 2.
So m equals 4 over 2 or
2.
2.
Oh, 2.
Well, now I can write my old equation, right?
Yeah.
Y equals, what's m?
2.
X plus 1. So what you've just received is 3 different tools to use in your toolbox to find the slope and the y-intercept. Which way is best?
Whichever way you want to be.
Yeah, whichever way feels comfortable to you. And I will tell you that some equations, like when they have an equation where you can see it go 1, 2, 3, 4, that leads so much to just regress back to 0. It's just too easy. Does that make sense?
Yes.
I mean, while I love to do a lot of work, no, I'm lazy. That's just too easy. You can find your slope by finding the difference in y over the difference in x. Or you can do it with a fancy equation.
Can you just leave it as a fraction, like 4 over 2?
Always. Well, 4 over 2 is not a good fraction. Why?
Because it's 2.
Because it's 2. You can write 2 over 1. Slope can always be written in a fraction because it's rise over run, right? So if you're doing yourself a favor, you just want to remember that it's 2 over 1, you can write it as 2 over 1. When you get to the questions, if they're multiple choice and they say y equals 2x plus 1, just remember, hey, that's 2 over 1, same thing.
Wait, are these just examples of how to do it?
Yes, these are some different tools to do the same thing we've been doing. The only thing we're changing for proportional lines is that starting point is not at 0. Wookiees are saved, and they live long with non-proportional lines.
But I don't like the Wookiees.
Well, then you'll have to make some proportional lines later. All right, any questions?
No.
Bye.